100 years ago, a man looked through a cardboard box and saw the Eiffel Tower in 3 dimensions. Today, we talk to machines that think. In between, a 30-ton computer that filled a room, a chip that changed civilization, a gold rush built on pure electricity, and a question nobody's answered yet. This is how computers conquered the world, and what they did to us along the way. Let's start with a question. Why do humans build machines at all? Not to survive. Animals survive. We build machines because we have this restless, almost neurotic urge to extend ourselves. To see further, hear more, remember longer, feel things we've never felt before. And that impulse? It's ancient. But this story starts in 1910. Picture a parlor in London, gas lamps flickering, a family gathered around a wooden box with two eye holes. They're passing it around like it's some kind of miracle. Inside, two slightly offset photographs of the Eiffel Tower. But when you press your eyes to it, suddenly, it's three-dimensional. It floats. It's real. This was the stereoscope, and it was civilization's first hint that machines could fake reality well enough to fool the brain. We weren't just looking at pictures. We were trying to enter them. Move forward 10 years to the 1920s. Electricity was no longer a novelty. It was everywhere. And with it came something strange and beautiful, the theremin, an instrument you play without touching. You just wave your hands near two antennas and out comes this eerie, ghost-like music. Think about what that meant psychologically. A human being separated from the machine by empty air, still controlling it. The concept of an interface, of influencing technology without being tethered to it, was born. Then the Great Depression hit. 30% unemployment, breadlines stretching around blocks. The world was broke and desperate, but in living rooms across America, something was glowing in the dark. The tube radio. 80% of American households tuned into the same broadcasts. Franklin Roosevelt's fireside chats, Jack Benny's comedy, the news delivered in real time into your home. For the first time in human history, an entire civilization was experiencing the same moment simultaneously. Shared reality, delivered by machine. Inside those radios were vacuum tubes, glass cylinders filled with nothing, heated by a tiny filament, capable of amplifying electrical signals. They were large, they ran hot, and they broke constantly, but they worked. And they planted a seed. You could encode truth, music, voices, emotion, into electricity. That seed was about to become a forest. Here's something nobody tells you about the computer revolution. It was an accident of war. It's 1943. The Allied forces need to calculate artillery firing tables. Wind speed, gravity, shell weight, trajectory. The math for a single table took a team of human computers, mostly women with math degrees, 6 months of manual calculation. And by the time they finished, the weapons had changed. The military had a problem. They needed machines that could think faster than humans. Enter ENIAC, the Electronic Numerical Integrator and Computer. Unveiled in 1945, it weighed 30 tons, as much as 3 full-grown elephants. It occupied an entire room at the University of Pennsylvania. It used 17,000 vacuum tubes, and when they all ran at once, they generated so much heat that the room hit 80 degrees Fahrenheit even in winter. But it could do in 1 hour what 6 human computers did in a week. That's not just speed, that's a different category of capability. ENIAC wasn't faster at the same job. It made previously impossible jobs possible. Code breaking, nuclear calculations, weather modeling. Then the war ended, and something magical happened. The factories that had been stamping out tanks and artillery shells suddenly had nothing to make. Engineers who had been building weapons suddenly had no weapons to build. And all this surplus knowledge, electronics, circuits, cathode rays, got redirected into something nobody expected. Toys, appliances, consumer goods. This was the birth of consumer tech civilization. Technology stopped being a tool of governments and became a product you could buy. By 1951, we had the UNIVAC 1, the first computer sold commercially. The Census Bureau bought one. So did the U.S. Air Force. A television network used one to predict Eisenhower's election victory. Live on air. The public was stunned. They called it a mechanical brain. Meanwhile, 3 scientists at Bell Labs had been quietly working on something that would make the vacuum tube look like a horse and buggy. In 1947, John Bardeen, Walter Brattain, and William Shockley invented the transistor. It was the size of a paperclip, used a fraction of the power, never burned out, could switch on and off millions of times per second. Engineers hated it. When a vacuum tube broke, you could see it. It would fog up, crack, glow orange. You'd pull it out and replace it. With a transistor, you needed a microscope just to find the problem. So they kept using tubes. And in doing so, they nearly missed the revolution that would eventually make all of them irrelevant. By 1960, IBM had built an empire. 70% of the computer market, everywhere you looked. Banks, universities, government agencies. The same blue logo, the same humming mainframes, the same IBM engineers in their white shirts and ties. They weren't just a company, they were an institution. But IBM had a problem, a deeply frustrating, expensive, customer-enraging problem. Every IBM computer they'd ever built was completely incompatible with every other IBM computer. If you bought a Model 7090 and then upgraded to a 7094, every single piece of software you'd written had to be rewritten from scratch. Every program, every calculation, every database, gone. Businesses were spending more money migrating between computers than they were actually using them. The solution was the IBM System 360. Announced in 1964, what one IBM executive called the biggest gamble in corporate history, it was a family of computers, from desk-sized to room-sized, all running the same architecture. The same software ran on the smallest model and the largest. You could upgrade without losing anything. It sounds obvious now. At the time, it was revolutionary. The System 360 changed civilization's relationship with information. Suddenly, businesses could build on computers instead of just using them. Airlines built reservation systems, banks built transaction processing, governments built social security databases. The modern bureaucratic world, the one that tracks your taxes, processes your paycheck, manages your hospital records, was built on the System 360's architecture. And then NASA did something extraordinary. They used System 360 computers to plan a moon mission. In 1969, 12 humans flew to the moon and back using onboard computers with less processing power than the calculator watch you can buy for $5 at a petrol station today. We went to the moon on the equivalent of a digital alarm clock. But while IBM was celebrating its dominance, something was happening in garages and university labs that they completely missed. In 1958, Jack Kilby at Texas Instruments etched an entire circuit, transistors, resistors, capacitors, onto a single sliver of germanium. The integrated circuit, the entire ENIAC, all 17,000 tubes, shrunk to something you could lose between the sofa cushions. And then Gordon Moore, co-founder of Intel, made an observation that would define the next 60 years. Computing power doubles roughly every 18 months, while costs halve. Moore's law, not a law of physics, a law of human ambition. IBM saw none of this coming. They were drunk on their own success, ruling a market that was about to be eaten alive by miniaturization. The future wasn't going to be in their building-sized machines. The future was going to fit in your hand. For 30 years, computers were things that other people used. Banks used them, governments used them, universities used them. If you were a regular human being in 1975, a computer was as relevant to your daily life as a particle accelerator. Technically impressive, completely irrelevant. Then three things happened in 1977 on almost exactly the same day. Apple released the Apple II, Commodore released the Pete, Radio Shack released the TRS-80. Three personal computers sold in department stores aimed at ordinary people. They didn't know what ordinary people would do with them. Neither did ordinary people. The early software was mostly for hobbyists. Simple games, basic accounting, text adventures where you typed "Go North" and the computer told you there was a cave. It was nerdy. It was weird. And it was the beginning of everything. Because here's what nobody understood yet. The barrier to computing wasn't hardware. It was language. To use a computer in 1980, you had to speak its language. Command lines, syntax, arcane abbreviations. You had to think like a machine to talk to one. And then Steve Jobs visited Xerox PARC. What he saw there, a graphical interface, a mouse, windows on a screen, he understood immediately in a way Xerox hadn't. Not as a technical curiosity, as a revolution in communication. If you could point at things instead of typing commands, if the computer learned to speak human instead of humans learning to speak computer, then everyone could use one. The 1984 Macintosh launched with a now legendary Super Bowl ad. It put a mouse in your hand and icons on your screen. It was the moment technology stopped requiring translation. Grandmothers wrote letters on it. Children made art on it. Musicians composed on it. The machine had learned to speak human. But hardware alone wasn't enough. Someone needed to build the bridge for the people who wanted to control computers. Not just use them, but who found traditional programming languages as readable as Sanskrit. That person was Guido van Rossum, a Dutch programmer who spent Christmas break 1989 in Amsterdam writing a new language in his spare time. He had one rule: if you can't read the code out loud and have it make sense, it's too complicated. He called it Python. No semicolons, no memory management, no cryptic syntax, just clean, readable logic that looked almost like English. For every student in the classroom, print their name. Actual Python, actual English. Almost. Python was designed for the human brain, not the machine's clock. And it quietly planted a seed that would eventually bloom into something nobody, not even Guido, could have predicted. The 90s arrived, and with them, the internet, and everything changed. Fast. In 1991, a British physicist named Tim Berners-Lee posted the first web page from a server in Geneva. It was a page about how to build pages. Nobody paid attention. 2 years later, a college student named Mark Andreessen built Mosaic, the first browser that could show images alongside text. Within 12 months, the web went from 130 websites to 10,000. Within 5 years, it had 50 million. Here's what the internet did that no technology before it had ever done. It connected people to other people at zero marginal cost. Not just information, not just data, people, their ideas, their creativity, their loneliness, their commerce. The dot-com gold rush began. Billions of dollars poured into companies with no revenue, no profits, and names ending in .com. It was the 1634 tulip mania all over again, a collective delusion, powered by genuine technological excitement and human greed. Pet food websites raised $300 million. Online grocery delivery burned through cash like rocket fuel. Then in March 2000, the NASDAQ peaked and collapsed. $5 trillion of market value evaporated in 18 months. But here's the thing about bubbles. When they pop, the bad ideas die. The infrastructure survives. The fiber optic cables, the server farms, the protocols, they were all still there. And the next wave of companies, Google, Amazon, Facebook, built empires on the rubble. The internet had rewired civilization. You could shop without leaving home, read any book ever written, talk to a stranger in Tokyo at midnight. The world had shrunk to the size of a screen, and then it shrunk to the size of a phone. January 2007. Steve Jobs walked on stage in San Francisco and held up a rectangle of glass and aluminum. An iPod, a phone, and an internet communicator, he said. Are you getting it? These are not 3 separate devices. The iPhone wasn't a better phone. It was a pocket-sized personal computer that happened to make calls. Apple spent 6 months on the keyboard software alone because typing on glass had never been done before. Nobody knew if it was even possible. It was. And by 2010, more people accessed the internet from phones than from computers. Think about what this means. Every human being with a smartphone now carries more computing power than the entire world possessed in 1969. The Apollo missions, the ENIAC, the IBM System 360, all of it, combined, sits comfortably inside your pocket, and you mostly use it to argue with strangers and watch videos of dogs. But also, you are now available to the machine 24 hours a day, 7 days a week. The boundary between human life and digital life dissolved. We didn't step into the matrix. We invited it in. By the 2010s, Python, the Christmas holiday hobby, had become the backbone of the digital world. Instagram, Spotify, Dropbox, NASA, CERN, all built on Python. And then machine learning exploded, and Python was already there, waiting. Libraries like TensorFlow and PyTorch turned it into the operating system of artificial intelligence. For most of computing history, machines followed instructions. You told them what to do, step by step, and they did it. They were fast and tireless, but fundamentally dumb. They couldn't learn. They couldn't adapt. They couldn't surprise you. That changed in 2012. A neural network called AlexNet, trained on millions of images, looked at a photograph and recognized what was in it. Not because someone programmed every possible visual, because it had learned to see. Like a child learns to recognize a dog, not from a rule book, but from 10,000 examples. The implications took a few years to sink in. Then in 2022, ChatGPT launched. 1 million users in 5 days, 100 million in 2 months, the fastest product adoption in human history. For the first time, you could have a conversation with a machine and genuinely not be certain whether you were talking to a person. Not because the AI had been programmed with the right answers, but because it had read essentially everything humanity had ever written and learned from it. This is the pattern of the last 100 years made visible. We build tools that extend our capabilities until the tools become capable of extending themselves. Vacuum tubes extended our memory. Transistors extended our speed. Networks extended our reach. Smartphones extended our presence. And now AI is extending our cognition, our ability to reason, to create, to decide. Every 30 years, roughly, computing power multiplies by a factor of 1 million. The ENIAC took a room. The iPhone fits in your pocket. What fits in your head? 30 years from now? But here's the question nobody is asking loudly enough. What are we losing as we gain? We outsourced memory to Google. We outsourced navigation to GPS. We outsourced recommendations to algorithms. Every time we hand a cognitive task to a machine, we get efficiency. And we lose a little of the friction that makes us human. The getting lost that leads to unexpected discovery. The forgetting that forces us to reconstruct and understand. The next 100 years won't be about whether AI is smarter than humans. It will be about whether the combination of human and machine creates something greater than either alone. In 1910, a man pressed his eyes to a wooden box and saw a three-dimensional image for the first time. He was trying to enter reality through a machine. 115 years later, with artificial intelligence, augmented reality, and brain-computer interfaces, we're still trying. We have always been trying. The species that asks, "What if?" doesn't stop. It just builds better questions. So, what will you build next?